Okay, so this is a progress update on a UI library that I'm working on. And for this update video, this is going to be the first time that I'm going to go ahead and let the video be listed publicly on YouTube. Every previous update video that I've been doing has been unlisted. So since you may have arrived here through the algorithm, I'd like to first spend a moment giving an introduction to the library itself. So, hi, I'm making an immediate mode UI library in Lua for Lua-based game frameworks and engines. I've implemented backends for it for the Love game framework and also for the Lover game framework, which is similar to Love but specialized for 3D and particularly for VR, which is, what we're in right now. When you're using it in Lover in VR, you get support for these, I'm calling them world space windows. It's, a floating panel in 3D space, and it hosts the UI content. If you're in Love or in desktop mode on Lover, you still get access to like a 2D, full screen experience. The library is still very, very early in development. It's not even a 1.0, exemplified by the fact that this progress update talks about images, which I've only just now added. Up until this point, everything has just been text and simple shapes, but every UI library needs to be able to draw images, so that's what I've been working on recently, and that's what this update's about. Okay, so first, we've got just your regular normal image widget. It's got a very simple call signature. You just call iui.image and you pass it your image object and it just draws the image. But there's many ways that you might want to customize how the image is drawn. And so the image widget also supports a lot of style keys inside of the style table stack. Again, this is the first video that's going public. If you're not familiar with style table stack, I've got documentation for it, but basically it's a table. You can put keys and values in it, and then widgets are free to look at the keys in the table to customize how they look and behave. So in this case, there's a couple of keys supported by the regular image widget. And the first one I want to talk about is the fill mode, which specifies how the widget fits and sizes the image inside the bounds of the widget itself. Normally the image widget has a transparent background. I went ahead and put in a black background so that you could visualize the bounds of the image widget itself and see how it's sizing the image inside of it. So the default fill mode that we've got is called aspect fit. It respects the aspect ratio of the image you're drawing in the sense that it doesn't distort it. It'll scale it up and down uniformly, and in aspect fit, it will scale it up as big as possible so long as the image doesn't spill outside the bounds of the widget. And the trade-off of it is that if your widget bounds don't match up with the aspect ratio of the image itself, then you'll get like letterboxing and pillar boxing. Similar mode available is called aspect fill. Likewise respects the aspect ratio of the original image, but this time it stretches the image as much as it needs to in order to completely fill the image widget. But the trade-off of that is that cropping might be involved if the aspect ratios don't line up. We've also got the fill mode, and this one no longer respects aspect ratio. It just stretches the image horizontally and vertically in order to fit the entire widget at the cost of distortion. But every pixel or fragment of the image widget will be filled up with every texel of the image. And then finally, we have the center mode, which draws the image at its original size and just centers it inside the widget. Now, you've noticed some of these fill modes involve cropping if the image spills outside of the bounds of the widget. That's controlled by another style key for clipping to bounds. By default, in code programmatically, clipping to bounds is not set by default, and if the image spills outside the bounds of the widget, then it will go ahead and be allowed to to draw bigger than the widget itself. If you don't want that, you can turn on clip to bounds, and then you get the cropping behavior. The final style key I want to talk about is the filter mode. Now, if you've done any sort of graphics programming, you're probably familiar with two of these, the linear and nearest mode. Linear does linear texture filtering, so the fragments are shaded by linearly interpolating between the nearest texels, which is great for like high resolution art viewed at least from a distance, but if you get close to it, but if you have lower resolution art and you get close to it, you can kind of see like a lot of blurring going on. Doesn't look that great. If you've got things like pixel art, the nearest neighbor filter mode can look better. Nearest neighbor works by just sampling whatever pixel is closest to any given fragment and then just taking that fragment color. It results in a nice blocky appearance that is good for pixel art. But it has some downsides where if you're scaling it smaller and by a non-integral factor, you start to get some like distortion and like pixel crawl going on. And in VR, this doesn't show up so well in the video, but what I'm looking at right now is looking like the pixels are really kind of shimmering and crawly. So there's this sort of hybrid filter mode available called Smooth. And I'll try to overlay a graphic on top of the video that shows what's going on here. In the Smooth mode, it maintains the blocky appearance of nearest neighbor filtering, but it anti-aliases the edges of the texels, and that should make something that it can make pixel art look better in 2D screens, and in VR it avoids the aliasing and shimmering. So it's great for pixel art, it's great for VR. Okay, so next is the 9 slice. All right, so 9 slice is a neat technique that you can do when you're drawing like user interface controls and you want to draw some sort of like bordered image, and you want to be able to draw that image at various sizes, but you don't want to be like going back here, you don't want it to be stretching out and distorting it as you're giving it different sizes. You want it to instead do it as here, where the border is kind of remaining the same thickness no matter what. The corner radius is looking good no matter what. So this is a technique called 9 slice, where you can take an image and you can cut it up into 9 different chunks, and then the 9 slice image widget will keep the corners the same size and then stretch the edges and the center as necessary in order to fill the bounds of the widget. Doing this allows you to get these UI control borders that remain nice and good looking no matter what size you put the widget at. So similar to the regular image, this also supports the filter style key. So I've got this set to smooth because it's pixel art, but if you have something that is like a higher res kind of image asset, the linear style would look better, but because this is pixel art, this just makes it look blurry, so I'm gonna set it back to smooth. So that's the 9 slice widget. All right, so this is I'm really excited about this one. So what are we looking at here? Well, a smiling face, but beyond that, we are looking at an image here that, despite being a fairly low resolution image, it's no matter how close I get to it, it continues to look, nice and smooth and sharp. It's a style of image rendering that allows you to take low res images and do like this flat shading style, but keep the edges of it look nice and sharp. It's a great way to have arbitrarily scaling art that has the appearance of almost like rendering vector images, but it's done using regular rasterized images. So what's going on here? We're using a technique called MSDF, or multi-sign distance field rendering. Sign distance fields have been around for a long time, but this sort of image rendering technique, I think, was popularized by Valve and Team Fortress 2. They introduced sign distance fields for this sort of flat image rendering, but the technique has been sort of refined by other folks since then. This is a version of it called multi-sign distance fields. The inspiration for me adding this to this library comes from Lover itself, for how it handles text rendering. So if I get really, really close to text, you can see it's not getting pixelated. It's continuing to look good, even though I'm shoving my face right up to it. And the thing is, I would think that this sort of really good looking text rendering would be sort of like a baseline for rendering text in VR. Text should just look great no matter what angle you're looking at it from or how far you are from it. But the thing is, I've noticed it's not universal on VR platforms. Like, I believe Vision OS and Android XR both use MSDF text rendering or similar technique, but like Horizon OS on the Quest that I'm using, or the Steam VR system menus, I think both of them have text that like starts to get pixelated if you get close to it. I'm not sure how well this is showing up in the video, but like the invite text in particular looks kind of blocky when I get that close to it. I really like that Lover has it, and I wanted to bring that sort of just, you know, really high quality rendering that holds up at any distance. I wanted to bring that to images, so I made this. And on top of that, I'm showing a sort of an additional feature on top of just regular MSDF images, which is what I'm calling layered MSDF images, where I can take multiple images and assign them colors and then stack them on top of each other and make them render as if it's one, you know, multicolor image, just by stacking images on top of each other. And so this is going to be great for things like toolbar icons. And it supports, you know, these fill modes like you'd expect. But can also be used as like very simple, minimal, single color things for literally small details. So throughout this video, there's been a couple things you've been able to notice that are actually using MSDF images. So if you look at the checkbox here, the check mark is an MSDF image. If you look at the inside the file menu, you see these disclosure indicators. That's an MSDF image. And then even the cursors that we see are MSDF images. So you look at the split view little cursor there, that's an MSDF image. So like lots of little details, and no matter how close I get to the UI, it continues to just look great, and I just absolutely love this. Now, I mostly added this for, you know, VR where we're at right now, but these images are awesome even if you're making something in like the Love framework in 2D, because these give you essentially free high DPI monitor support, right? You create a single image, and then on a regular DPI display, it'll render fine. But then if you do a high DPI display, like if you're on a Mac with their Retina displays, their high DPI displays, it will look nice and sharp and smooth on those displays as well. So it's awesome. I'm really happy to have it. And so there's one final type of image control I want to demo in this video. And it's something that kind of brings together everything that I've demoed so far. It's pretty simple. It's just a 9-slice MSDF layered image. Not that much to talk about it, but it's a combination of everything I've talked about before. It's an MSDF image. It looks great no matter how close I get to it. It's a 9-slice image. I can resize it around like that. Pretty straightforward. All right, so that's everything I had to show for this progress update. If you'd like to try this library out, I've got some links in the description below. Like I've said, it's still very much a library that's very early in development. It is really not production ready yet. There's all sorts of missing functionality, like for example, like here in VR, I don't even have any sort of VR keyboard for text entry, so I just can't even enter text. But if you'd like to try it out, the repositories are available. I'd really appreciate feedback on it, for anything that doesn't work well, doesn't make sense, any bugs, anything that could be designed better. For my next update, I want to work on a couple of features like list views. This is just a standard scroll view. I want to be able to implement a list view that takes in a number of items, a row height, and a callback that generates widgets. And the list view will invoke that callback for every item that is visible on screen, but not anything that's off screen. And so that should be a view that can scale like to as many items as you want. If you wanted to have like 10,000 items, it would work fine. And that'll be really good for performance. And speaking of performance, I also want to start experimenting with using object pools. Right now, the library just, it allocates quite a bit of memory and it just drops on the floor, and I haven't had any performance issues so far. Like I've mentioned, I'm running this on a Quest and I haven't had any performance problems, but I've got enough memory activity going on right now that when I'm logging it out, I can see that there is like garbage collections going on. So I'd like to start experimenting with memory pools and seeing if there's any performance improvements I can have with that. And I also want to implement what I'm calling inner windows. Right now, the UI will kind of fill its entire screen. Since we've got these world space windows in VR, you know, the UI will fill the entire world space window. But if you're using a 2D like Love, a 2D experience. It'll fill the entire screen. If you're developing a game dev tool, lots of folks like to put like little windows in like the corners of the screen while still showing the game content. Inner windows will enable that instead of right now of like just filling in the entire screen. So that's what I'm going to be working on next. Not sure when I'll make the next video. We'll see how things go. But with that, that's everything that I wanted to talk about. So I'd like to thank you for watching this video, and I will see you next time.